yeah, as before, you couldn't watch those videos if you have an account, but it's not needed for the module. So I'm gonna jump over the first two steps a little bit and start with stuff we already covered a little bit, which is the foreign key constraints. So for our example from the task database, let's have the ER diagram. We have the status ID and the user ID foreign keys in the task table. We have the most basic constraints, which I think we already covered a little bit, which is that they reference some other table, which is a constraint on that value. It says, well, this value can only contain an ID that exists in the other table. And if you, as we saw before, if you try to break those rules, it's not going to be possible. Just going to get an error back. I don't think there's anything more to say about foreign key constraints. No.
We basically touched upon it before. So.
Yeah. So let's talk a little bit about storing stuff in my SQL or SQL databases in general that are not totally, what do you call it? Logical. It's an easy mistake to make, at least. I've made it before. So let's say you have a web shop or some sort of shop where you sell stuff, t-shirts or something, and you want to sell in all sorts of different currencies, like dollars, krona, dirhams, whatever you want to sell in, euros. You want to store the prices of all these products. So what would you store them in? What kind of data type would you store the prices in?
It should be integer.
Integer. So if I have something that's
number should be number, not text.
So let's say I have the price of a t-shirt is 42 krona and 21 öre, right?
And it should be float.
To float?
It should be number.
Yeah, but do you mean float or so like?
In that case, it should be float.
Okay. So let's give you a riddle here, which is what's this going to give me? So I can do the integers first.
Yeah.
What's that going to give you? What's the result of that going to be? This is a JavaScript. But
yeah, it's true or false.
Yeah. Okay. What's this going to be?
It's also true.
Do you know why?
No.
So basically it's because not all floating point numbers have a precise way to be stored in the binary system. So this is not 0.3, this is actually 0.30000 something 4. So floating points are really good for very fast calculations where precision is not, where like a crazy amount of precision is not needed. Like this is obviously fine if you're doing 3D graphics or graphs or whatever it is, graphics, whatever it is. But if you're doing some finance, money-related stuff, then suddenly you will find that your accounts don't match. So if you want to store something in a database that has something to do with prices or currencies or whatever it is, in MySQL there is a thing called a decimal. And that is a way to store numbers with decimal points precisely. So you can define it like we did before. We create a table with the decimal data type. And I know in JavaScript there's probably a library that takes care of it for you, because there's no decimal data type in JavaScript. There's only integer and float, or double, whatever it's called. But this makes sure that all the prices you store are stored precisely, and if you do any calculations on it, that you don't get these weird errors. Or it's not an error, it's expected behavior from floating point, but it's an easy error to make. So the example this was the first or second job I had, I did a web shop that did PayPal payments. And when you get a confirmation back from PayPal, they tell you how much money was paid from that client. And then you compare it with what you have internally, and if they paid as much money as you wanted them to, then you give them whatever they ask for, right? The T-shirt or whatever it is. And I had to calculate the VAT of the number, and I used floating points to do that. And sometimes the VAT would not be correct, because PayPal calculates the VAT correctly, and I calculated it incorrectly because I used floats. So I was like 0.001 off, which means that the VAT was not correct, which means I declined the order, which means people didn't get their product, which means people were mad. So I had to fix it. So always store it in MySQL terms and in something called decimal. And in JavaScript, I guess there's a library for it. Some people also store it in cents, like euro cents or dollar cents or whatever. So you always use integer math, and then you just present it with decimals on it. So if you have some price, then instead of doing this, you do this instead. And then when you present this price, you just have that in your logic that it is actually cents and not, or øre in this case, and not kroner. But this has the limitation that if you want to store prices at more than 2 decimals, then you can't really do that easily. Because let's say that you are selling something in euros, and then someone comes along and wants to sell it in Vietnamese dong or something that's not worth very much. Then you have to use a lot smaller numbers when you convert and stuff like that. So it's easier to just use decimals from the get-go. Let's get back here. Yeah, date and time we touched a little bit on. So there is the date time. Where did we go? There's the date and the date time fields. There's also something called the timestamp, which is basically just, I guess, I don't know if you've heard it in JavaScript terms, but it's the amount of seconds since 1st of January 1970.
1970, yeah.
Yeah. And you can use that in MySQL as well. We can find it here. Yeah, the timestamp, data type. There we go.
There are some subtle differences between the two, date time and timestamp, but I think for the most part they're the same.
Let's try and create a table and say create table. Let's just do see if we can do that.
You have a comma too much.
I do?
After columns.
So insert into time test values. But I created it. Didn't I create it with a timestamp?
Yeah. Maybe the now function works on both.
Yeah, maybe. Okay. Identical with date time.
Okay.
Okay. Maybe that's a new thing in the newest version of MySQL, I guess. So yeah, actually this is no longer the case. It seems it's defaults to date time no matter what you do. But you can store timestamp values, which is I think you can do that. Select to Unix. Isn't then just Unix timestamp? Yeah. So it stores the amount of seconds since 1970, 1st of January. It's used a lot in the Unix and Linux world for timestamps and log files and events and all that stuff. which it's fine for. If you're doing other stuff, I'd suggest to use date time. You store date and time. You need to be aware that when you're storing, there we go. When you're storing dates and times in MySQL, make sure you store it in what's called UTC, which is Universal Coordinated Time, I think it stands for. Because if you have an assumption that the time, let's say it's 2:21 in the morning, can that, so it's whatever day of the year, and it's 2:21 in the morning. The normal assumption is that time can only happen once every day, right?
Yeah.
But that's not true, because when you go to winter time, that actually happens twice. So if you I think it's in November or whenever it is, when you go back to the winter time, you put the clock back 1 hour. So if, let's say, what day do we what day do we change to winter time? Maybe not to winter time. Yeah. So the 28th of October, right? So that is the date 2018-10, right? 28, 02, 31, 45, right? So in Danish time terms, that thing actually happens twice and not once.
Yeah.
So let's say you have a client that orders something at 2:31 at night. Then you're not sure what 2:31 it actually was, because it happened twice. So you always store it in what's called UTC, which is a time that doesn't change, and it doesn't have summer and winter time. So it's kind of like what's called GMT, I think it was called. So you always store timestamps in this value and in database in this time zone, and then when you want to present it to the user, then you have the possibility of presenting it as Danish time or whatever it is, British time, American time, and you're going to run into this as soon as you have a system that supports more than one time zone. So if you do it, let's say you make a web app for Denmark, then we're only in one time zone, so it's not such a big a problem. But if you have a web app that is being used in the US, they have, I think it's 2 or 3 time zones. They have Pacific time and Eastern time, and I can't remember. They have 2 or 3 time zones. And time zones don't always stay the same. Sometimes they change. So stuff like in Libya, for example, 5 years ago or something like that, they cancelled, I think it was summertime, with no warning whatsoever, like a week before it was supposed to happen. So the Gaddafi just said, I don't like wintertime. Okay. In what? Turkey?
Yeah.
Oh, I didn't know that.
Also in Boston, Iran.
Yeah, probably. And you can even have people who live 5 miles apart, and as soon as you cross the border, the time is different.
Yeah.
Because the president of one country said, oh no, we want another time. And then suddenly it's 8 o'clock in the morning, and then you pass a line, then it's 9 o'clock, and you go back, it's 8 o'clock. So it's important to store it in something that is universally correct no matter what you do, and then you can always convert it to the local format when you present it to the user. That's the easiest way to do it.
Yeah, so basically do it as the last step.
Yeah. And MySQL has support for, for converting between time zones. So if you have a time stored in UTC in the database, you can convert in MySQL. I don't use it very much. See if I can find it. Yeah, it's called convert TZ. There it is. It needs a bit extra install steps when you do it, but it works just fine. I always do it in the app itself instead of in MySQL. This, for example, this converts this timestamp from GMT to MET time. I don't know what MET is, but it's not the time zone. Europe, Moscow, currently. Yeah, I think that was it for the time. Any questions? Or? Okay.
So when we need to, for example, it's more related to the date, for example, is there any library when we need to, like we are making one app for fetching the flights, airport flights. So in that case, we need to import some library to extract all the airports in our app. It's in the database, or we need to do something in the front end.
I guess I don't know that much about the airline industry. I know that you could probably, there are a lot of libraries that does the conversion stuff for you. I don't know what it's called in JavaScript. There probably is something on the data object.
Yeah, I guess you could either use the built-in data object or you could use Moment.js or something like that. It's a bit easier to use, I guess.
Yeah, I remember this one. I've used this before.
It has like conversion from UTC to local time.
I know I've used this before for JavaScript, which it does all the different time zones and everything you could imagine with times and calculating time, difference in time, all that stuff. Yeah, there's an example here. Today minus 10 days. Oh. There you go. So that's a good library for that. I know in Python there's a library for it as well. In PHP there's a date time class, and let's cover the first stuff we actually talked about. So we've talked about one-to-many and many-to-one relationship quite a bit. I don't think we have covered.
It's no class.
It helps to click the button. Yeah. We haven't covered many-to-many relationships that much. So let's try and create a many-to-many relationship in the what's it called, the task stuff that we have in this database. Here, let's get the ER diagram so we can see it. So let's try and make it possible for a task to be assigned to more than one user. So you have a task that can be assigned to me and you, or no one, or everyone, or whatever it is. So how would we do that in this case? Yeah, but in this case we need many-to-many, because you as a user can be assigned to many tasks, and a task can be assigned to many users. So how would we do that? You can think of it as, I think Fleming said this last time, you have two one-to-many relationships that are combined.
We have to make a separate table.
Yeah.
And pass the IDs to that table.
Yeah. So how would we? Let's try and make it. So in this case, we have these three tables that we have in the diagram as well. So we'd need to create a third table. Let's use the workbench instead. That's usually better. What would we need to do in this new table?
We have to pass the ID, primary key.
Yeah, ID of what?
And also the primary key of the task table.
Yeah. I can't remember the actual. really bad memory, so I have to look up stuff. There we go. And then task ID, same thing. And then we need for these to reference something, right? What should they reference? How should I write this constraint?
The first constraint should be the user table.
Hmm.
So the constraint there is a user ID.
Yeah, we can do that. And now again, I can't remember how to do this, so I'm just going to cheat. I'm going to steal this. References user ID on the cascade. And let's do the same for the task table. Maybe we can references.
There's no way you can put them in one line.
There's what?
There's no way you can put them in one line.
We
Yeah,
could.
You can put them in one line. It's just easier for the.
It's easier to see, especially if I don't if I have to show it on big screen and stuff. It's a bit easier to see. Okay, let's see. So we missed one thing here, because you're not supposed to be able to assign the same task to the same user more than once, right? So here I can insert. Let's say you have user ID 5 and then task ID 1. So I can insert 5 and 1 in the table. But I don't want to be able to do it twice, because then you're assigned to the task twice, which doesn't make any sense. That you'd have to work twice as hard on the task. But so what we want to do in this table is create a primary key that limits your ability to do that. So we've always had primary keys that was just called ID, and it was one number and it was unique and it was just going 1, 2, 3, 4, 5. You can also do what's called a combining primary key.
Yeah.
Composite, yeah, exactly. A composite primary key, where the primary key is actually these two fields together, because then you cannot insert duplicate entries in the table, which makes good sense here because you're not supposed to be able to duplicate assignments to tables. Let's actually try that here. And we just do, or maybe we need to do that up here. I actually can't remember if it's just comma, isn't it? User ID, comma, task ID. Yeah. What's the error here?
I think you
I have a comma.
Train comma.
Yeah, I do, yeah. So this is the, let's just zoom out so we can see everything. There we go. So now we can see everything in one photo. So now we've created a table that has two fields that references these two tables and has a primary key that is a composite primary key. Let's try and create it. Let's see if it blows up. No, it doesn't actually. And then we'd actually need to delete the old reference from the status table. Also, status. Well, isn't it delete column? What would it be?
The task.
Oh yeah. Task. Let's drop the delete column. I can't just delete it.
I think it's
Yeah. And we need to delete the index as well. I can't remember how to do that actually, so let's just look it up. There it is.
Google is being helpful.
Yeah, Google is drop index. Needed in the foreign. Okay. So then it's drop constraint. Is it just drop constraint? I can't remember. Yeah, there it is. It's auto table. There it is. See if that works. No? I can't remember how to do that actually.
I think they're doing, they had a dot notation.
Let's see.
Drop foreign key.
Yeah, drop the constraint.
Ah.
We have to put one.
Maybe drop foreign key. Let's see. Yay, it works. Okay. There we go. So now we have a new table called user underscore task. Now we can actually do something in here. I don't think I've shown you this yet, but this is a really good feature in Workbench. If you have a database that you got from someone else or that you don't know how it's constructed, you can use this feature called, it's a bit hard to read, but it's called reverse engineer. And we basically just select the database, we select the table, use H1, press next a million times, and then we have a new diagram for this table that shows us the relationship between. So it looks like the old one we had. Let's just make it a bit smaller so we can zoom in. So it looks like the other one we have. Now we just have an extra table, so we can compare it with. There we go. This was the old one. We have no extra table between user and task because it's just one-to-many. One task can be assigned to one user, but one user can have many tasks. In this case, we have a new table, so you can assign tasks to many users and users to many tasks, which is the basic many-to-many foreign key. Or, as Fleming said last time, it's a one-to-many, but two of them, because this can have many users and many tasks, so it's kind of two many-to-one relations joined in one table. It becomes a many-to-many. Let's say we wanted to know when a user was assigned to a task. What would we do then?
Assign a task.
Yeah, so let's say I assign you now. I assign Darian to task 5 right now. What would I need to know to remember when I assigned it to him?
So it should be created date.
Yeah.
We select the
On what table?
on the task table.
But that task, so let's say I assigned Darian first, and then you were right after.
Yeah.
Then I need to have 2 created dates.
We select user.
So I want to know when the relationship was created between you and the task and you and the task.
Yeah, then we select the user and the created date from both tables, user and the task.
But we still...
And do you need another table?
You don't need another table, no, because you already have the table. So I basically want to know when. Let's try and insert a relationship. Show tables. Select ID command name from user. Select ID command title from task. Let's just do this. So I want to assign user 1 to task number 3. Let's say that. Values. I can't remember which. Is it user first? It is, right?
Yeah.
So user 1, task 3, right? So now I have an entry in the user task table, which, by the way, if I try to do that again, it's going to fail because I already have it. So this was created 5 seconds ago when I did. What if I wanted to record when I insert something? Just try it. So now I assign Arika to task number 2. So I want to save when I do that. So we need an extra property on this table.
Task created.
Not task created, but when it was assigned.
Yeah.
So this table user underscore task. What?
The task is already existing.
Yeah.
But,
I want to know when I created the link between the user and the task.
Yeah, then there is
it needs an extra code.
assign.
In what table?
User task.
Yeah, exactly. Because then we know when we created something in user tasks. Let's say we alter the table user tasks and column.
Should we call it assigned?
Yeah, assigned date and time. I think this would work, right?
Yeah.
Exactly. So now we have null in there because we didn't have it when we created it. Let's try and assign it to task number 1 as well. Perfect. So now we know that Arika was assigned to task number 1, 11:03 today. So you can have a table that is responsible for the many-to-many relationships that also has more than just IDs.
So if we check the created date, it's not affected.
No, the created date of the
they are
task is not
separate.
affected. So the task created is let's say we have this application and I create a task
Yeah.
just because I want to remember to do it or have someone do it. Then that was created today, and then tomorrow I find out that Ina is the one who's going to do it, and then I assign it to Ina, and then
Different.
we have different timestamps for the two.
This is assigned, the other is created.
Yeah, and then I can assign it to Darian to help her or whatever, and then we still will. He was assigned the day after. You were assigned the day after that. Yeah. Let's go back to there. Any more questions about many stuff?
Let's first go back to the table.
To the table? Yeah.
You said somewhere that if we assign the task to 2 people, they need to bring an error.
Need to what?
When we assign it to 2 people,
Yeah.
because I see there we have user ID, it's only one.
Oh yeah, let's try and assign it to.
So let's try
We can add maybe
Let's try and insert this one. So let's actually assign user 2 to task number 1 as well. There we go. So now we have user 2 assigned to task 1, 11:05. We have user 1 assigned to task 1 at 11:03.
But if I had you are saying that it will display an error somewhere. Yeah.
Yeah, you cannot add the same. So if I did this again, it's going to fail because I can't assign it again to user. Yeah. I can't do the same again. So let's actually try, before we talk about normalization, let's try and make a little exercise, which is this example. So we have this, I'm actually just going to copy this into something else. Here it is. So we have this JSON file, which is an example of articles for a blog, let's say. This, you could see this as example output from a JSON service that shows you articles from a blog, whatever it is. And now you have to design the database behind this. So you have an array of article objects. So this is one article, ID 1. It has 2 authors. There's a title, it has some content, and it has 2 tags. So you can probably guess that there is at least minimum one many-to-many relationship behind the database behind it. So try and first draw the ER diagram like this for the table, and make the tables that need to exist behind this API, that would need to exist behind this API, and connect them with relationships to each other. And any questions or anything, just ask. We will walk around and help you. I'm just going to stop the recording.